Good morning, everyone. In the last session, we discussed about the important concept to call linked list here. Linked list is one of the implementation of this particular list interface. So if you observe carefully, now what exactly it is doing here? Here if you see add method. So whatever the way we are inserting here, in the same way, we are trying to get this particular values here. Okay, now what I will do, so I'm going to comment this all the steps here, whatever we discussed so far here. Now here, simply I will call this particular method here, add method. Okay, so add method I'm trying to give as a 10. Now here, so 50 and 40, so 30 and 20. Now if I'm trying to print these values, if I'm trying to print these values, now what happening internally? So how these values are going to print internally? In the sequence array, like whatever the order we are inserting, in the same order we are trying to get here. Here you can see 10, 20, 30, 40, 50. Because here I'm trying to print, and in the last, if you see here, here also I'm trying to print. So because of this, now we are getting the two times the same output here. But if you see the same order, now if you go to this particular collection set, like collection list here, now what happening internally, even though if you are trying to use it, so this also will become same. Now it is also, it will try to provide the in the sequence order. But what is the differences between these two here? What is the differences between these two implementation classes? Now the array list and linked list, what exactly it is doing internally. Now this is what we need to understand here. So to understand these two concepts here, what exactly we are going to do here. Now what we observe so far here, so that we need to understand here. Okay. Now if you see here, array list basically it is going to support the dynamic array creation. So for example, dynamic array creation is nothing but here what you need to understand here, whenever I'm trying to create an array with a by default size. For example, okay, so for example, if you'll see default capacity is 10. For the array list, default capacity is 10. Now we can insert up to 10 elements. Now, for example, now if I'm trying to inserting 20, what happens internally? So up to whatever the default capacity we are having, it is trying to insert the 10 record, and later it is going to create a bigger array list. Okay, it is going to create a bigger array list because the 10 element default it is going to allow, but the size we given as a 20 here. Okay, so 20 records at a time it is not going to be inserted. Okay, so here if you are using the default capacity, array list automatically it is going to create a one bigger array list here. So based on the current capacity, it is going to multiply. So now, so the 70% of the current capacity, it will multiply and it will create a new bigger array list here. Okay, so this is one important we are going to get. But in the linked list, now what happens internally? So linked list basically it is not going to store in the arrays concept. It is going to store as a node concept. So here we don't need any capacity here. So how many records we want to insert here? It will try to create a each and every node here. For each record, internally it is going to create a node concept here. The node can contain the previous node and value as well as next node. But only the difference is here it is going to make the previous node and current node references here. Previous node and current node references. So this is what we need to understand here. Okay. So these are about the differences between array list and linked list. Now, whenever I'm trying to create whenever I'm trying to remove the record from the array list, now what happens internally? If you provide the index here, so for example, I want to remove the value from the second index location. So what happens internally? Directly we are going to provide the index here. Now whenever we provide the index, directly it will come back to this particular index location. It will try to delete this. Okay, it will try to delete this particular index. Whereas whenever we are trying to delete the record from the linked list, now what happens here? Now, even though if you provide the index number, now what happens? It will keep on search the record first. Okay, it will keep on search the record, whatever the record is available under the second index location. So once it is identified, it will try to remove the particular record. So remove is nothing but it is going to remove the linking concept, like previous node and next node linking concept, it is going to remove here. So this is what we need to understand. So deletion as well as creation. Okay, so now here in the both location, it is going to have a dynamic growing behavior, either like in array list as well as linked list. So it is going to have same automatically growing nature, but only the difference is here deletion. So deletion basically what exactly it is going to have. So in the array list, based on the index location, it will try to remove the object directly. But whereas in the linked list, first it will identify the record and later it will try to delete here. Okay, so this is what we need to understand. So differences between array list and linked list. Now here we can go for the dynamic increasing of the size, or we can decreasing the size in the array list. Okay, so this is we need to observe the differences between linked list and array list here. Now here another important concept to call set here, because so this is the part we discuss as of now. Like collection is a super interface. Now here we are having list here, and here we are having set here. So the third one is queue. Okay, so these are the three main interfaces. Like the main interface is collection, and these three interfaces are extending. These three interfaces are extending from this particular collection here. Now, so this part we as of now we completed. Now here the list is implemented by array list here, and the second one is linked list here. Okay, array list and linked list it's completed. Now another important okay, another important section is set. Now what you need to understand here, set is another interface here. We need to understand how the set is implemented internally. So first, what is the implementation of the set? Okay, so we'll see this. We have a different type of like implementation classes. Now the first one is hash set. The first one is hash set. So we'll discuss about the hash set, how exactly it is going to be implemented internally. Okay, now we need to understand this hash set here. Let me create one example on this. Okay, hash set demo. Now this hash set demo, it's contain the main class here. Now under this main class, now I'm going to create a object of this particular hash set here. Okay, now hash set is also internally, it is using the concept called generics. Now what I will do here, we discuss about this string and integer. Now we'll discuss about the character. Okay, so character type I'm trying to give you. Now here, so character hash set here, not required character. Now here if you see hash set constructor. Now how many types of constructor we are having? Now we need to understand here. So to understand this, what exactly it is going to do internally. Now let me create a constructor first here. Okay, hash set here. Now these many different type of constructors we are having under this particular hash set. The first one is default constructor, and second one is hash set collection is hash set int comma float. So this the third constructor which is expecting 2 parameters. Now the fourth constructor which is expecting 1 parameter. Now the fifth constructor which is expecting 3 parameters. So now we'll try to identify one by one how each and every constructor is implemented internally. So first we'll discuss about this particular default constructor. Now you can see, so this is the public hash set, but internally if you see, we are trying to create a one more object here. Now what exactly this object is doing here? Okay. Now if we observe here, so internally this is the constructor we are calling. Now hash set internally it is going to create a object of this particular hash map. Okay, hash map it is creating. Now if we observe, okay, hash set internally it is extending from this particular abstract hash set and it is implementing from this particular set interface. Okay, so this is we observe. But another important section, now why they provided this, line number 96. Now if you observe carefully, now this is the hash map. Hash map, the key we are expecting as a E and value we are expecting as a object. Now so far we discuss about the only object type, that is called E. But whenever I'm trying to show you this hash map, whenever I'm trying to show you this particular hash map, is expecting E comma object here. Now if you see what you are understanding it, so this parameter basically will treat as a object here. Okay, but here the first one will try to identify as a key and the second one will try to identify as a value. Now you can see key value pair. Okay, so hash map internally it is trying to work with the key value pair. So the E it is going to play as a key role and the object whatever we are having here, so this object it is going to play as a value role and this particular E it is going to play as a key role. Now carefully observe hash map internally it is going to work with the key and value pair here. Okay, now whenever we are trying to work with the hash set, now what we are doing here, we are trying to work with internally hash map. Okay, internally we are trying to work with the hash map, but here so key is going to play important role. Okay, every time we need a unique key. So if you are trying to provide the same key, now what happens internally, the values are going to be overridden. Values are going to be overridden. So this is what we need to understand regarding this particular hash map here. Okay, now observe carefully how this hash map is going to work internally. Okay, now what you understand here, to understand this particular hash set, first we need to understand the hash map so that we can easily understand this particular hash set here. Okay, so to understand this particular hash map, now what we need to understand first. Okay, so to understand this particular hash map, first we need to understand the map interface. Okay, so far we discussed about the collection. Collection basically it is a part 1. Okay, and map here. This is basically part 2. Okay, so because map is going to store as a key value pair. Map it is going to take as a key value pair, whereas collection is going to take as a object as a parameter. So object as a the enum type here. Object as a enum type here. So if you see set, if for example set we are having, now internally we are providing this particular E, whereas map, now map here we are going to use key and value. Okay, map key and value here. So this is what we need to understand here. Now see the differences, set we are going to store as an object, map we are going to store as a key value pair. Okay, now so to understand this particular hash set is the one of the implementation of this particular set interface. Okay, now what we will do, first we will go for the part 2 here. First we need to understand the part 2, how this particular part 2 is implemented internally. So to understand this particular part 2, what exactly we can do? Now here So we need to go to this particular collection.txt. So before going to discuss about the collection.txt, and here we need to call the map. Okay, so map here. Now you can see, now whenever I'm trying to show you this map here, this is the interface. Okay, map is a interface. So in the part 2, map is a super interface. Getting the point? In the part 2, map is a super interface. Now what exactly we need to understand here? Now what we need to understand regarding this particular map here? So what are the methods we are having here? First we need to understand what are the methods. Now this is a collection.txt. Now if you observe here, I'm going to use this collection.txt so that we can create all the okay. So now here we need to discuss about the important section about the map here. Now I'm going to create a public interface map key value pair. Okay, interface map key value pair. Now what is another important section here? Now if you see this, here we are having a method called into size. So we already discussed about the size method in the collection interface. Now you can see into size. So it is going to work as the same, like currently how many records are inserted into this particular map, it is going to provide the same information here. Okay, now what are the additional methods? Now is empty. Is empty is also similar method, whether the map is empty or map is having any records here. Okay. So now what exactly another important section, like what are the another method we are having under this particular map interface. So now if you go to this particular below, contains key. Like how we observe the contains method. How we observe the contains method. So based on the parameter, the given object is available or not. So same way, this is also similar method. Like here we are checking along with the key and value. So both we are going to check here. Okay, here we are going to check both contains key and contains value here. Now what about this particular get method? Now if you see this particular method here, this is the key and this is the value. So whenever we are calling the get method, here we are passing the key. Okay, here we are passing this particular key, and this method it is trying to return as a value. Now what you observe here? So when we want to know the value of this particular key, we can call this get method and we'll try to provide the proper key so that we'll try to get this particular value here. So that we'll try to get this particular value here. So this is what we need to understand regarding this particular key here. Okay. Now here you can see we are having a one method called put method. So what exactly this put method is doing now? So carefully observe put method. Okay, get method we observe whenever we are providing the key, it will try to load as a value. Now whereas this particular put method, now what exactly it will do? So it is expecting the key and it is expecting the value. Okay, it is expecting the key and it is expecting the value. So this is what we need to understand the key value pair. Okay, it is expecting key value pair here. Now what you need to understand here? Now, what you need to understand basically. So put method here, we are going to provide the two parameters, key and value, so that the key and value, it is going to insert it into the map here. So whereas if you go to this particular collection, whatever this particular add method, so where we are having add method here. Now if you see line number 12, we are having add method. Now here we are providing the object. Okay, here we are providing the element. So whenever we are providing this particular element, now what exactly it is doing internally? It is trying to insert the record into this particular so array list or linked list. Like so far whatever we discussed, it is trying to insert the record into the both implementation classes. Now same thing. Now if you use this particular put method. If you use this particular put method with the key and value, it is also going to insert the record into this particular map. Okay, so this is the main purpose of this particular the method called put here. Okay, so here if you see another important method called remove method. Now what exactly this remove method is doing here? The remove method basically whenever you are providing the key, based on the key, first it will load the object and later it will try to remove this particular object. Okay, later it will try to remove this particular object. Now this is the purpose of this particular remove method. Now you can see put all. Okay, same way we discussed about the add all method. So add all how we implemented internally. Same way here we are going to use this particular put all. But if we observe here we are passing the map as a parameter. But inside the map, if you see, first one is K extending the question mark and V extending this particular question mark. Okay, in the generic concept, whatever we discuss here, the while code related concept here, similarly here it is implemented here. So here the collection of like map of this particular records we are going to provide. The map of records is nothing but key value pair records we are going to pass. Now using this put all method, we'll try to insert one by one record here. Okay, we'll try to insert this one by one record here. Now another method called clear method. So this is a similar method. It will try to remove all the objects from this particular map. Now another important section method called key set. Okay, another important section called key set. So what exactly the key set method is doing now? The key set method basically it will try to return the set of keys. Okay, so set of keys something like multiple keys it is going to return. Multiple keys it is going to be written. So this is what we need to understand here. Okay, this is what we need to understand. Multiple keys are going to be written here. Now here you can see values. Now whenever you are calling the values method, now it will return only values. This method will return only keys and this method will return only values. Because in the map we are going to store key and value pair. So if you want to load only keys, you can call this particular key set. Now if you want to load only values, now you can go for this particular values method. Okay, so these are the important method. Now you can see entry set. Now entry set basically what exactly it will do this entry set basically it is a one record which contain the key value pair. Okay, so it is going to return as a key value pair internally. Okay, it will try to return as a one by one record, so the record can contain key value pair. So this is the main purpose of this particular entry set here. Entry set. Now you can see set of and map of entry. Okay, set of map of entry. Set of something like multiple records. Under the multiple records, we are having the type called map.entry. Map.entry internally it is contain key value pair. So we'll see this. So this is an interface called entry. Now internally what we can do, we can load the get key and we can load the get value and so set value. Using the entry set method, we can set this particular value also. Here we are having equals method, hash code method. So we are having comparing by key here. So this is the another method. Now you can see this is the static method map.entry. Directly you can call this method. So comparing by key and comparing by value. These are the methods which are available under this particular map.entry. Okay, so now we'll see. I will try to copy these methods also. Okay, now I need to copy this first so that we can observe these are coming from the map.entry interface. So here entry basically it is the internal interface of this particular map here, so that we can make map.entry. We can easily understand from where this entry is coming here. This entry is coming from the map. Okay, so here you can see get key, get value, and here we are having set value. Now set value method, what exactly it is doing it? Now here directly you can set this particular value. Now whatever the value you set it, so it will try to return the current value. Okay, now this is the set value. Now equals method we'll discuss later, equals and hash code method. Now these are the static method. The static method something like comparing by key and comparing by value here. So if we want to compare the key and value, now what we can do, we can go for this particular comparing key and value methods here. Now another important method here, if you see, comparing by key is expecting the comparator. Now we'll discuss later what exactly the comparator will do. Okay, later we'll discuss about this particular comparator. Now what exactly it will do here. Now another one is same thing, comparing value using this particular comparator. Comparator as a parameter. Now first we need to understand the comparator, how the comparator is implemented internally, and later we'll try to work with this particular all the important section. So up to this is the map.entry interface internally provided. These are the methods. Now you can see, so this is the entry internally. One more interface is created. So this is not the outside interface, this is the internal interface, map.entry. Okay, because of that I am trying to create interface called map.entry. Okay, so up to this is the outer method. Entry set, basically it is a outer method. So this entry set internally it is trying to create a record called map.entry. Now this is the entry interface is contain the these are the methods here. Okay, now we'll go back to here the remaining method, what exactly it will do. Now you can see this is the default method, get r default. Okay, now what exactly we are doing, if you see this method here only it is giving the information. Now what exactly it is giving it, so get based on this particular key, provide the value which is available under the map. Now if the map does not contain the value, now provide the default value. Okay, you can see here v is equals to get key. Okay, v is equals to get key. Now what we are doing is, if this particular v not equals to null, now it will try to return the v. Otherwise it will try to return the default value. Here if you see this, here we are using the ternary operator. Here we are using the ternary operator. So this is what we need to understand regarding this particular default, get or default. We'll debug this method also, how it is implemented internally. Okay, so now you can see get or default. So default means you need to provide the value. If the value is not available, it will try to return the whatever the default value you are having. And another default method for each here. Okay, another default method called for each. What exactly this for each method will do? Now if you see, here we are calling the for loop. Okay, internally if you see this, here we are calling the for loop. Now we are calling the entry.getKey and entry.getValue. Value. Okay, we are loading key and value. Here we are going to call this particular action.accept. But here, now which functional interface we are providing? So this is a by consumer. Earlier we discussed about the consumer. Now this is the by consumer. The by consumer is expecting key and value. Now if you see this, so this is an interface by consumer and it is one of the functional interface. He is expecting the type and what exactly it is doing. It is a second input argument here. Okay, so this is what we need to understand. This method is not going to return anything. Okay, so here what we can do, we can call the for each and you can provide the either lambda or functional interface, whatever you want to do. Now internally it will try to repeat this and it will call this particular accept method here. Okay, so we'll see this how it is implemented. This particular for each method is also and replace all. So this is also one more default method which is available under this particular map interface. Now what exactly this particular replace all method will do? Okay, so what exactly the replace all method is going to do here? So to understand this, now what we can do basically here, same concept it is doing. So here again it is trying to load the one by one value. Now once we load, now what we are doing is here we are calling the function.apply. So whenever we are calling this function.apply, we'll get this particular value. Now what it will do? It will try to replace the value. From where we are going to get this particular replace value? Now here we are going to provide from this particular function called by function here. Okay, so this is also we'll see how this internally implemented the replace all method. So by name of the method it's saying that so we are going to replace all the values here. And so if you say this, put if absent. Put if it is absent. Absent is nothing but if the given value for this particular given key, if you don't have any record for this particular given key, if we don't have any record, now we'll try to put this particular records here. Okay, so this is what we need to understand here. Now let me copy this. We'll try to observe. We'll try to identify internal implementation of this particular method also. Put if the value is absent here. Now second one is like a default method, remove. Now what we are doing is object key we are providing, object value also we are providing. Now I'm using this particular get key, I'm loading the object value, current value. Now if the current value not equals to the whatever we provided, now what it will do? So it will try to checking the current value null or convert to, so whether this particular key does not contain any value. So we'll try to remove this particular false, and otherwise based on this particular remove key, we are going to provide the object we are going to remove. But if you see this, it should not match the current value or current value null and contains key. Whatever this particular contains key we are having, so that is also not available here. Okay, so these are the some different type of conditions here. We'll see later how this particular default remove method is implemented internally. Okay, so this is the default remove method. Now coming back to below, we are having lot of default methods. Default method purpose is basically what exactly it will do. Now, if you are interested, you can override the method, whatever the default method we are having. If you are not interested, now what we can do, directly you can call these methods. Okay, you can call these methods. Now it will try to create a, it will try to provide the with a default implementation here. So what is the default implementation? Currently whatever we are seeing, so this is, we'll call it as a default implementation. This is, we'll call it as a default implementation here. Okay, so now remove method we observe here. This is the remove method. Now this is the replace method. Okay, this is the replace method. Now what exactly we are doing this particular replace method here? What exactly we are doing this replace method? Now to understand here, now if you observe carefully, the replace method basically, if you see this, we are providing the key and old value and a new value. So based on the key, first we load the current value. Now we'll try to replace with the new value. Now you can see we are calling the get method. We'll load the current value, and if the current value not equals to the old value, okay, if it is not matching this, now we are trying to return this particular false. So if it is matching it, we'll call this particular put here. Using the put, we are passing the key and a new value. Okay, here the line number 115, whatever the method we are calling. So it will try to call this put method by providing the key and value here. So this is what we need to understand, replace here. So now if you see this old value, just we are checking here old value, new value. Now whenever the condition will not satisfy, it will go to here key and new value. Okay, so we are going to be replace the existing value. Now this is the one more method, replace. Now if you see this here, we are not providing any the old value concept. Simply we are checking. Okay, simply we are checking this condition. If condition will satisfy, we are going to call this put method. Same put method. Here also we are calling the same put method, and here also we are calling the same put method. But only the difference here, we are providing old value as well as new value. But this replace method, we are not going to provide old value. Directly, we'll try to provide the new value only. Now, whenever we are providing the new value, it will try to replace this, the whatever the value we are going to provide. Okay, so this is the similar method. Now you can see compute if absent. Now what exactly it is doing here? Now if you see, so this is also similar method. First we are loading this key, and if the key is null, like whatever based on this particular key, if you are not going to found any value, what it will do? It will try to check these conditions here. Now again we are having one more condition. Now we are trying to call this particular put method. But if we observe, this is one of the functional interface we are providing. This is one of the functional interface we are providing. So using the Java 8 related using Java 8 related mechanism. So we can call this method and we can provide. Now here if you see, we are calling the one method called apply. We are calling the method called apply. So apply, what exactly it will do? It will try to insert this particular record if it is not available here. If it is not available here. So this is what we need to understand. Let me copy this so that we'll try to debug the internal implementation of these are the methods, how it is implemented here. Okay, so now go back to here, additional methods call. Now same method we are having, but only the differences we are having by function. Earlier we given a function, now we are providing the by function. So by function, if you see this, is expecting, so with the different values like k and v, and internally it is extending, so one more v here. Okay, so old value and new value we are going to provide. So here we are having only the concept to call. Here we are having only the concept to call new value. But here we don't have the particular new concept here. So we are going to work with old value as well as new value concept here. This is what we need to understand regarding this particular same method. Now we'll see this similar method also. Now coming back to here. Now we are having, so default method. Now here also we are providing the same by function. Okay, now if you see this, if the old value not equals to null and if the old value is available, what we are doing is we are removing this. Okay, we are removing this. Now whenever we are removing, if this particular condition is not going to satisfy, okay, here if the new value is null, we will try to remove this. If the new value is not null, we will go to directly here, we will try to call the put method with the help of this particular new value. So we'll see how this type of methods are going to be implemented internally. Okay, so this type of methods, how it is going to be internally implemented. But what you are observing carefully, now if you see this, each and every method is expecting key value. Each and every method is expecting key, and here you can see value, and here you can see k, and here you can see value. Now the map is going to take care of key value pair, whereas the list and the set, it is going to take care of objects here. Okay, like a single parameter. Map is going to take care of two parameters, whereas the set and the list, it is going to take care of two parameters. Okay, so this is what we need to understand here. Now go back the below methods, what we are having is, so merge method. Okay, so now what we will do, we'll try to debug these are the default methods. Okay, here only we'll try to debug what exactly this default method. Now if you see this, all the default methods, all the default method basically now is expecting the functional interface type. Like functional interface, when we are providing, either we can go for the lambda expression or we can go for this particular functional method references. Okay, so any one of the concepts we can use. Now another important concept called off method. So what exactly this off method is doing here? So earlier when we are trying to work with this particular linked list, here we call the off method. So if you see this list.off. Okay, here we are calling this particular list.off method. 10, 20, 30 we are providing. Okay, same way the map also now is having map.off. Now what exactly it will do? We need to provide the key value pair. Okay, we need to provide the key value pair. Now if you see this, so this is also off method. Now this off method is not taking any parameter. Simply it will try to return the empty map. Now whereas if you provide the key and value, it will try to return as a immutable collection map and key1 and v1. K1, v1 is something like key and value here. Okay, key and value here. Now this is what we need to understand regarding this particular off method. Now another off method, now below if you see this, these are the two parameters. These are the two parameters we need to understand here. So like okay, key1 v1 and k2 v2, something like key1 value 1, key2 value 2. Same way if you see, these are the three methods. So it will like a 4. Okay, now you can see 5. So 6. Now if you go to here, K7, like key 7. Now if you see K8 is something like key 8. So 8 parameters we can pass to this particular method called off. Now similarly we can go for this particular 9 also. So key 9. If you want to pass key 9 here. Now lastly if you see this K10 also. Okay. So this off method up to 10 parameter is going to take. For example, if the values are reached to more than 10. If the values are reached to more than 10. Now what we are having? Here we are having concept called vararg. So this vararg also we already discussed in the previous session. Now here we are not going to provide the parameter. Directly we are giving these 3 dots. Directly we are giving this particular 3 dots. Now based on this particular count here. Now if it is length is 1. Okay. If not equals to length is 1, we are going to call this particular map node. It will try to return this particular section of code here. Okay, now internally what we are doing here, if you see this, here we are trying to creating a object array. Okay, here we are trying to create an object array, and internally based on this particular length, it will try to create, and it will finally we'll call this particular immutable collection map. Okay, but here what you need to understand here, so this particular section it is going to take care of vararg concept here. Okay, so to understand this, go to the previous recorded session. How exactly we implemented this particular vararg concept here. So this is what we need to understand regarding this particular entries here. Okay, now below what are the methods we are having? Entry method. So again it is a static method. Like a default and static method, we'll try to debug here only, so that we'll understand more how these particular methods are implemented here. Okay, now what we observe here. So first, map interface we are trying to discuss here. Map can contain these are the methods. Okay, map can contain these are the methods we are having here. Getting the point. Now we need to understand how the map is implemented here. So basically, what is the main purpose of this particular map here? Map basically it is going to allow key value pair, whereas collection is going to allow object as a parameter. Okay, so this is the main differences here, but remaining like a clear method, isEmpty method, like add method, whereas add method we will use in the collection, and in the map we will go for the put method. Okay, so like get method is also same. So we have some different method we are having under the map. Now we'll try to debug the one by one here. Now what you need to understand here, so now I'm going to comment on this. Okay, instead of comment out, now what we can do, we'll go for the one more class here. Here, map demo. Okay, so I'm going to use map demo. Now under this map demo, main method. Now here, so map we discuss here. Map basically it is a part 2. Okay, now how this part 2 is like how this particular part 2 is look like here. Now if you see this map here, now is expecting key value. Okay, now internally we'll have a different kind of implementation classes as well as interfaces. Now we'll go for the implementation first. So we'll see the internal interfaces, like which are the interfaces that are going to be extended to this particular map here. Okay, the interface concept we'll see later, but first we need to understand the implementation concept, so that it is easy to understand the set related, because we stopped at the set here. To understand the set, first we need to understand this particular map related concept. Okay, for that purpose we are discussing about this particular map here. Now coming back to here, now what you need to understand here, first implementation is for this particular hash map. So hash map internally it is going to take care of key and value. Okay, key and value. So this is what we need to understand here. So these are about the implementation of this particular map here, hash map here. Okay, so we'll see how this hash map is going to implemented here. Now, to understand this, first what we need to do, we need to create an object here. This is the hash map. Okay, hash map is expecting key and value. The key I'm going to provide as a key string. Value I'm going to provide as an integer. So if carefully observe, this is very important here. The key, what is the data type I'm trying to providing? String. Because the key and value, it is implemented as a generic here, so that we can provide any data type here. So this is the main advantage of this particular generic here. Okay. Now coming back to here, we provided the string and integer. For the another example, we'll go for the different data types here. Now what you need to understand here, how many constructors we are having. Okay, how many constructors we are having here? The first constructor is a default constructor, which is available under the third location. Now what about the first? Int and float. Okay, int and float. Now what you are observing, the first constructor, int and float. First parameter we are providing int, and the second parameter we are providing as a float. So int, it is a capacity. Okay, int, it is a capacity. Now float, once how much percentage of this particular hash map is completed, then we'll go for the new creation object. Getting the point? For example, so the capacity I given as a 10. Okay, the capacity I given as a 10. Now hash map, basically it is not going to allow all the 10 records. Hash map, it is not going to allow all the 10 records. Now 75% is completed. 75% of the hash map capacity is filled. So 75% is something like around 6 to 7 records. Okay, so 6 to 7 records are filled under the hash map. Now what it will do, it will go for the bigger hash map creation. It will go for the bigger hash map creation, and it will copy all the 6 to 7 record into the newly created hash map, and it will have a additional space also. It will have a additional space also. So that now again it will wait, and so the newly created also, if it is completed 75% here, now it will go for the one more creation, like it is going to create a new hash map here. So this is the way the hash map is going to be implemented internally here. Okay, so these are about the first parameter, the float related. So float, basically what is saying is ratio, like how much percentage of this hash map is created, then we can go for the new creation of object. So that is going to be provided the ratio concept here. Okay, now come back to here. Now what are the additional constructors? Now we observe this. Now the second one, only it is expecting the capacity. Only it is expecting the capacity. So what is the capacity we can provide? The capacity we can provide based on our requirement, like you can give 10, 20, 30, 40, 50, so whatever you are interested. So by default, what is the capacity? That we'll discuss now. And so the last constructor, which is going to take as a collection, like a map as a parameter. Okay, map as a parameter here, because if you see, they provided map type here. Now we'll see how this last constructor is going to be implemented. Now first we'll go to the default implementation. Now if you see this is the hash map. This is the hash map we are having. Now what we are doing is, so this dot load factor. Okay, this dot load factor, default load factor. Now what we are having, the default load factor. Now what we are having, this particular load factor. Now if you see this, so this is a initial capacity method, second constructor. Okay, now internally it is calling the one more constructor. But if you see this, so this is the hash map default constructor we are having. But I'm trying to identify one important section called this dot load factor is equals to default to load factor. Now here we are having the load factor called 0.75. Now whatever I suggested here, now if it is filled the 75% of this particular hash map, it is going to create the new hash map here. Okay, so this is we observe. Now what about default capacity? Okay, default capacity. Now if you see here, the line number 236, what is saying here, now this is the default initial capacity. How much? So here in the comment section, we are able to see 16. By default, how many records we can insert into this particular map here? Okay, how many records we can insert into this particular map? Now, how many records we can insert here? Something like 16. Something like 16 we can insert here. So this is all about the important section called hash map. Okay. Now going back to here, so default constructor. I am going to call this particular default constructor. Now whenever I'm trying to call this particular default constructor, so 16 object we can insert, and the load factor we are having as a 0.75. So this is clear. Now what are the additional constructor we are having? The additional constructor basically which is going to expect as a parameter. For example, 62 I given. Okay. For example, I given as a 62. If you see this, the message itself is saying initial capacity. Okay, initial capacity. Now I'm going to call this. Now here we are passing the initial capacity. Now see this. If the initial capacity is 0, you will get an exception. If the initial capacity greater than the maximum capacity. Okay. If the initial capacity greater than the maximum capacity, it will do the maximum capacity value is equals to this initial capacity. Okay. Now, if the load factor less than or equals to 0, or if it is a not null, now we'll get some different exception here. But, so if any condition is not satisfied, it will come back to here, load factor and the threshold. Okay. So now we are passing this particular initial capacity. So what is the maximum capacity we are having? So this is the binary type we are having, so that we'll try to use how many records we can insert it. Okay, so if you provide this one, it is going to store as a 16. Now we'll discuss later about this particular the object creation. Now we observe the by default how many we can store and explicitly how much you can provide here. Okay, so this is the second constructor. Now what about the third constructor? What about the third constructor? Now here I'm trying to providing same initial capacity. Load factor. So load factor, what is the value it is expecting? So it is expecting the float here. Okay, if you observe, it is expecting the float. But what is the value I given? Boolean value. So it is wrong here. Now, so I want to give as a 85F. Okay, so 85%. So once it is completed 85%, now you can go for the new object creation. You can go for this particular new object creation. So so you can keep same concept here. So this is what we need to understand here. And the last constructor, what is expecting here? Last constructor, it is expecting as a map as a parameter. So that I'm going to pass as a hash map. Now you can see. So these are the 4 type of constructor we are having under this particular hash map. These are the 4 type of constructors we are having under this particular hash map. Default constructor, so capacity constructor. Along with the capacity we are having load factor, and the last one we can pass as a map as a parameter. Okay, map as a parameter. Now we'll try to work with this particular default objects. Now we'll keep as it is. Now here I'm going to call the map dot put here. So whenever you are calling this particular put method, now what are the values we need to provide? Because put method is expecting 2 parameters. First parameter is key and the second parameter is value. So what is the first parameter we can provide? Key. So how we can provide the key? The key should be in the string format, because here we provided string and integer. String and integer. This string, it is going to take care of key, and this integer, it is going to take care of value. Okay, now I'm going to give as a key. So what is the key we can provide here? Key, something like okay, or we can go for the key 1, or we can go for this particular key 1, and value I want to give as a 10. Value I want to give as a 10. Okay, so this is the put method. Now first we need to insert the record into this particular put method, and later we'll load these particular records. And later we'll load this particular records here. So this is what we need to understand regarding this particular put and get method here. Okay, now let's observe how we can put this particular each and every record. Now I'm running in the debug mode here. So now if you see this, all the constructor we are calling, finally we reach to this particular put method. Now I'm going for this particular internal implementation this. Okay, now you can see this. So to understand this particular hash map, first here, this is the first method we are calling. So put method, what is the key? Key value. Okay, what is key? So if you see this is the value and this is the key. Okay, key we are having key 1, value we are having 10. Key we are having key 1 and value we are having 10. Now, if you observe carefully, we have a method called put value, and internally we have a one more method called hash method. Okay, hash method, but if you observe carefully, what is the parameter we are passing? The hashing method, we are passing a key only. We are not passing the value. Okay, so value, you can provide duplicate also, but key, you cannot provide the duplicates because keys are unique. Getting the point? Keys are unique here. So because of that, you need to provide the key values is unique. Now, based on this particular key, basically what we are doing is we are trying to generate the hash code of this particular key. Okay. So what exactly this hash code will do? Now we'll understand how the hash code is going to be generated here. How this particular hash code is going to be generated. Now I'm calling this particular hash code. If you see here, now finally I reach to this particular hash code here. Now what I'm doing, if the key is null, we are returning 0. Okay, if the key is null, what happens internally? The hash code, it will try to return as a 0. But current example, we provided it is not null. Okay, current example, we provided this particular key, it is not null here. Now whenever it is not null, now what happens internally? Whenever if it is not null, what happening internally? So we need to understand the important section called, we are calling the key dot hash code. Key dot hash code. So key dot hash code is nothing but directly it will go to the string class hash code method. Now the hash code mechanism we need to observe now. Now if you see this hash code. Now we are under the which class here? So string class. We are under this particular string class. Now whenever we are having under this particular string class, now we are calling the hash code. So this is the hash code logic is going to provide it, executed. Now it will try to return the hash code value. Now if you see this, we are having this much. So how much we are having? So hash code is 32,88498. So finally, we are getting the hash code value of this particular key. What is the key we provided? Now here we are having key 1 is a key, and for this key 1 hash code is something like 32,88498. Okay, 32,88498. Now what exactly this particular hash code will do now? Now whenever we observe this particular hash code, we are calling this particular put value now. Okay, now I'm going to call this particular put value. Now if you see this, here you can see hash code we are getting and the key we are getting. Okay, and later here we are going to get a value also. Value we are getting 10, and this is the boolean evict related. Now we are passing as a true. Whenever we are passing as a true, now what you need to understand here? Whenever we are passing as a true, what you need to understand here? If you see this here, what we can observe carefully, So tab is equals to table. What is the tab basically? Table, currently it is null because we did not inserted any record here. Okay. Now tab dot length. So what exactly this tab dot length is now doing here? What exactly the tab dot length it is doing now? So what you need to understand basically here, you need to understand the the important section called. So this is the table we are going to create a records here. Now we are checking it because all the conditions are satisfied. As of now, we did not inserted any records here. Okay. So whenever we did not inserted any record, now what you need to understand here. So first record we are going to insert here. So whenever we are trying to inserting this particular first record, so this particular condition is going to be satisfied here. Now when the condition is going to be satisfied here, what we are doing? Resize. What is this particular resize will do now? What exactly this particular resize will do now? If you call this particular resize method, now if you go to this, so this is the resize method we are having it, and internally, so this is the table. So currently table is null because as of now we did not inserted any record. Now we are going back to here. Old table, if it is null, now we are trying to return as a 0. And if the old table is not null, we'll go for the another important section called old table dot length here. Okay, so this is what we need to understand here. Now here you can see what is the old capacity we are going to get. Old capacity is 0. Why we are getting 0? Because it is a current record we are trying to inserting it. Okay, so because of this now what exactly it is doing it? Because of this, now what you need to understand here, threshold we are getting, threshold also 0. Now new capacity, new threshold. What is the new capacity and new threshold? We are trying to get as a 0 only. Okay, now after this, so what you need to understand here, now what you need to understand here, if you observe first condition, if the old capacity greater than 0, currently old capacity it is not 0. Okay, now when the old capacity is not 0, now what you need to understand here? What you need to understand is now we need to go to this particular old threshold 0. Now old threshold greater than or equal to 0. So this is also not great. This is also not satisfied because here why it is not satisfied here? Here the as of now the threshold we are having 0. As of now this threshold we are having 0. Whenever we are having 0, now it will come back to here the below if condition. Finally we reach to this particular else section. Whenever we reach to this particular else section, now what is the default initial capacity? Something like 16 we are getting, and new threshold. Now what is the new threshold we are getting? Something like 12. Okay, so what you understand here, the load factor, based on this particular load factor and default capacity, it is going to identify the up to how many values we can store here. Okay, capacity is 16, but up to 12 records are finished here, it is going to create the new bigger hash map here. Compared to the current one, it is going to create a new bigger hash map here. So this is what we need to understand the regarding this particular hash map here. Okay, so now observe carefully. here threshold. So we observe the whatever the threshold we are having, that is we initialized here. Okay. Another one is now here we are trying to create a node concept here. Okay. So this is very important. Now we need to understand here in the hash map also. In the hash map also, we are trying to creating a node concept here. Okay, we are trying to creating a node concept here. So what exactly this particular node concept is going to be provided internally. Now what is the capacity? Capacity is now 16. Now if you observe carefully, it is a array type here. It is not a single type here. It is not a single type. It is a array type here. Now whenever we are having this particular array type here, now what exactly we are doing here? Now 16 node concept we are going to create here. 16 node array concepts we are trying to create in here. So each one it is going to create under the one more node concept here. By default we are going to create the 16 nodes here. So this is what we need to understand here. This is what we need to understand this particular concept here. Okay. So after creating this particular node array, now what you need to understand here. Now come back to here. So this is a new tab here. Now all the elements are null because as of now we did not inserted any records here. So we are calling this is a new tab and we are inserting into this particular table here. So finally we need to understand the table concepts, how it is going to be provided internally here. Okay, so how it is implemented internally. So this is very important section we need to understand here. Okay, so old table. So as of now, old table we did not inserted any record. Because of this, it is null here. Okay, now we are going here. So finally, whenever we are calling this particular resize here, so it is going to create a table structure and it is trying to return this particular values here. So we observe this. Now, so resize we are calling into this particular tab and we are calling the length. So that is we are initializing into this particular n here. Now if you see, so tab we are having, as of now we don't have a record here, and length we are having, so that is something like a 16 we are having. Okay, so this is what we need to understand regarding this particular as of now how the put value is implemented. Now, so if you see this if condition and here tab, okay, n minus 1. So what is the n minus 1? 16 minus 1, 15. So that we are initializing into I. In the 15 index location, if we are having any record, so that is going to be loaded into this particular P. And if it is null, so here we are doing the around 4 operations. First, what is the operation we are doing here? N minus 1. Now n minus 1 value we are initializing into this particular I. Okay, we are initializing into this particular array. After this, we are loading from the array. We are loading from this particular array. If the value is found, okay, if the value found, that we are trying to initializing into P. If the value still it is null, so this entire condition is going to be satisfied here. Okay, entire condition is going to be satisfied. Now observe carefully what exactly we are doing here. What exactly we are doing now. So condition is satisfied because the current record it is returning null. As of now, we did not inserted any record here. Because of that, now it is going to satisfy this particular condition. Here we are calling the new node. Okay, here we are calling this particular new node concept here. So whenever we are calling this particular new node, what is doing internally? It is going to create a new node. So you can see new node, hash code we are providing, key we providing, and value we are providing, and next. So next node is null. Okay, next node is null. So this is the way the records are going to be created internally. Now once it is created, what we am doing? Tab I. So what is the I value currently? What is the I value? 0. In the 0 index location, the newly created record is going to be inserted here. Okay, so this is what we need to understand regarding this particular put to method. Okay, how it is inserted internally. So we'll try to debug one more time regarding this particular put method, how it is implemented. Okay, so what you understand so far? So hash map is also internally, it is going to use the concept called node concept. So initially, it will create all the nodes here. So based on the nodes here, it will try to insert one by one node here. Node array it is going to be created. Based on the node array, it will try to pass the values here. So this is all about the hash map here. So far, whatever we discussed. Okay. So any questions? Okay, so if you don't have anything, so I'm stopping the session up to here. We'll continue tomorrow. So we'll try to debug one more time how this particular hash map is implemented internally. Okay, so we'll continue tomorrow so that we'll understand here more important about this hash map. So once a hash map is completed, it is easy to understand the set related concept because so set internally it is going to use the concept of this particular hash map. Okay, so we'll continue tomorrow. ఆగుతావా